We have to find a moment m that will keep the system in equilibrium whenever an input force of 240 newtons is applied to the point A. And since theta is given to be equal to 90 degrees, we can say that this force vector will be directly applied vertically. So there's no x component in this force vector. And to solve this problem, we're going to use the expression that the sum of forces, or the sum of moments about D is equal to 0. And we can use this to solve for the required one. So to start with, we're going to first find the y component of the force at position B. So to do that, we can say that the sum of moments about point C is equal to 0. And we can write that as negative 240 times 250 minus b of y, the y component of the force, times 160. And set that equal to 0. And we can solve this for b of y. And we get a force of negative 375 newtons. And we can now solve for the y component at the point C. So to solve for the y component at the point C of the force, we can say that c of y minus b of y minus 240 is equal to 0. So we can now plug in b of y, and that will give us c of y plus 375 minus 240 is equal to 0. And solving for c of y, we get a value of negative 135 newtons. We can now use the expression of the sum of moments about D is equal to 0, which we can write as m, where m is the moment that we're trying to solve for, minus c of y times 300 is equal to 0. So now we just plug in c of y. So we have m minus 135 times 300, set that equal to 0. Should be positive. So m plus, since c of y was negative, so we do m plus 135 times 300, and this will give us a value of m that is equal to negative 40.5 Newton meters.